Hello, ladies and gentlemen. Today I'd like to talk about a book called The Structure of Scientific Revolutions by Thomas S. Kuhn. So, what is this book about? This book is about, essentially, that the developments in science, as we know them, at least from the Western perspective, can be divided into things called paradigms. Paradigms, as you may or may not know, as it's been used in the common vernacular since the 1960s in which this book was written, essentially means a group of ideas that are accepted as true for the time being. And so in this, he describes this in the terms of scientific theory. Mr. Kuhn, or Dr. Kuhn, I should say, is talking about a situation in which, generally speaking, one set of ideas is accepted over another set of ideas. Let me give you an example. So the ideas of, for electricity is prescribed in this book. Talks about how in the 1740s and around that time period, a lot of people like Ampere, Coulomb, Volta, and so on, developed a lot of the theory of electricity. However, the more practical side, that is that of Gray and Benjamin Franklin, people like that, they basically took the ideas and they built on them and established a new paradigm based off of further experimentation and discovery that challenged theories and ideas that were set forth in the previous time period. So a paradigm is basically a group of ideas, and every subset, every major subject, physics, chemistry, biology, astronomy, and so on, they all have these major ideas to them. And for these are what the paradigms are talking about are those theories. And so the reason why this is relevant is because prior to this time period, in this book it addresses how the history of science was essentially kind of like the history of philosophy. The history of philosophy essentially was tracking the ideas of the Western world limitedly, from the Greeks in order to more modern time period, or usually to the late 19th century, early 20th century. That's when it would diverge. So you would have the ideas of the pre-Socratics, which were people before the written dialogues and ideas of Socrates. So these are your individuals, pretty much anybody prior to Socrates was in this category. Now, then you had Plato writing Socrates' dialogues, which became Plato's works, of course, the Republic, and so on, Timaeus, and so forth. Then you had the works of Aristotle, his student, which developed the morphology and the structure of biology and many other ideas of physics and how the world worked. Basically, there was a topic around at that time. Aristotle made some sort of comment on it. And then so forth. We built on Aristotelian ideas. And then we got later on, then we hit about the ideas of perhaps St. Augustine. And then it basically skips the Middle Ages for the most part, except for maybe Boethius, and maybe like St. Augustine. And then it just keeps going from there. Then you get ideas of like Francis Bacon, Copernicus, Kepler, Huygens, and Newton, Leibniz, and you just keep going on. So the idea of this is very limited. Like you're hearing the greatest hits, essentially, of what we consider. Well, you could say the same thing with the history of science. It's kind of the same thing. You would hear, Avogadro came up with this constant. You would hear, Gauss came up with this idea, Euler came up with this idea, and so it would just list these ideas in the history of science. It didn't really give you these people had to do this and they failed at this, but this guy took on that idea that failed and he changed it a little bit and then it succeeded. Like, you didn't really get that in the history of science until more recent times. And so this book really was kind of important because it established the idea that, like, men are not islands, because in this context we're talking mostly about men. So he's trying to say, like, hey, you know, if it wasn't for the contribution of all these other people, you know, we would not have a lot of our scientific discoveries, which I think is true. And he comments in the book, in the middle of the book, about Lavoisier and the ideas of, what's his name? It starts with the P. Planicy, I think his name is. And he, you know, the discovery of oxygen and so on, and how, you know, they basically built upon each other. And that would not happen if they weren't talking. Once again, you know, you had the idea of, let's see, I'm trying to think what other notes I put. This is why you keep notes, because we're just talking here. This is not a full comprehensive review. There's literature on this. This is a famous book, but yeah. So it also talks about, like, with the paradigm idea, it keeps going with this. It talks about paradigms must allow the replication of these theories and should present ideas in which could be tested further that should be different from the predictions of the previous paradigm, which obviously, you know, at first they think ether is used, or, you know, that miasma theory. And then you change to, okay, wait, there's germs by people like, you know, I forget the guy's name. Is it Pasteur? Yeah, I think it's Louis Pasteur. And they challenge the ideas, and then they could be tested. Okay, are germs real? And then it also talks about how, like, in these paradigms, they will put forth ideas, and sometimes they get challenged. Like, a lot of people didn't believe in germ theory. And another famous case in which science paradigms were challenged was when the Soviet Union became, you know, a separate entity from the West. It really diverged intellectually, especially with the, you know, I mean, we're talking like 1930s, 1940s, that they did not believe in Western genetics as we know it. Like, they believed that they believed in the pseudoscience, and I don't necessarily remember the agriculturist guy. It starts with L. Legivskiv or something. And he basically didn't believe in genetics, and he thought, oh, well, if you just mix plants together, you're going to get new plants. It's kind of like, you know, color theory, but for plants. And what happened, because of this mass implementation of this incorrect agriculture information, a lot of people ended up starving to death, because if you're not growing food in the correct ways, then you're going to have famine and other problems, you know, if you don't respect the land. But I digress. So it talks about how, like, not everybody agrees with what's even communally accepted. And it talks about, like, you know, other ideas such as, you know, utilizing ideas also that are not necessarily correct but may have a good basis. So it talks about, like, Ptolemy's idea of approximation of, you know, the movement of planets. It's not precise, but it can be used for some basic calculations, and just as a general reference, not perfect, but, you know, because if you know anything about planetary science, then you know gravity is a major force, and gravity was not even considered even during Isaac Newton's day, nonetheless, thousands of years ago. So, it's very interesting ideas. It's a little dense, so this is, you know, someone I was talking to before compared this to Mikhail Foucault, and, you know, his ideas of asylum and mental illness, and I can definitely see it. You know, it's written in a very, what's the word? The word I would be looking for, it's written in a way that, dialectic. It's written in a way, it's very, like, there's a lot of pedagogy involved. And if you don't understand some of the basic ideas behind some of these concepts, then you may not know. One of the major things, for example, that he cites that is necessary for development of a paradigm shift, especially, is that there should be some sort of anomaly that people notice, but it cannot be explained with the science that exists there. And so he'll be talking about, how people would experiment to try this out. For example, with electricity, Benjamin Franklin, the kite and key experiment, putting the string to the sky, then putting the key at the end and watching the key move around because of the particles and the static electricity causing it to bounce, basically. A lot of people at that time, especially outside the scientific community, thought that lightning was caused by God. And so he proved some of the elements. From these also, it was either before or right after he developed the lightning rod, because there was an essential need for this, and it caused a really big paradigm shift, especially where lightning strikes, when they would hit a building, because these buildings were made out of wood and didn't really have any sort of protection to them, it would burn down a building. And some of the burning was really bad, especially on the churches. I mean, it would kill hundreds of people. So a lightning rod was really essential because it would hit the rod, like a finger, and then it bounce off somewhere else. It would go to the area of least resistance. So this was very important for development of colonial societies or European societies, and by the end of it, Franklin was considered a hero, essentially. So highly respected at a time that he could utilize this. Okay, let's see what other notes I got. Okay, yeah, problems of paradigms that you can, it's not comprehensive. It needs to be built upon. And one thing Thomas Kuhn talks about at the end of the book is how it's interesting how back in the olden times, it was very common for historians to read a lot of philosophical science and major papers and so on from these great minds, but they weren't very concise and to the point. So you'd have to read a lot of them in order to get the main point of some things. But nowadays, and for 150 years, you can read a textbook and it'll talk about the main theories and the corollaries that go along with this. And this very samey kind of education all the way up to the college level, it gives people a lot of foundation that they can build upon to tackle issues that are brought about by new paradigms. It's very efficient, even though it's very narrow-sighted. And, as an undergraduate, when I studied computer science, I always figured, why do they give us these, they don't let us dive into research. And the main reason is because you got to have that foundation in order to build upon it. So that's a big deal. And that's different than some of the other things like the humanities, social science, where you can dive into research quickly. So let's see. Okay. So the notes I wrote. I think we covered just about most of it, but I just want to make sure. The major points I wrote. Let's see. Yes. The problems with the not being comprehensive, it shifts the ideas of, how we approach problems. For example, if we think, we have to do A, well, that's limiting, and which is interesting because if you look at stuff like the Millennial Prizes, which are these complicated math problems that have only had one or two solved since 100 years ago, they were prescribed by David Hilbert, the famous physicist and mathematician, more of a mathematician. And so, these are a lot of these are very theoretical, but they're important if they can be solved because the application to other things, they intertwine like a web, kind of like string theory or something. So that's very big. Let's see. Okay. See. Yeah, and so it talks about how scientists, when they write papers, the opinions they're getting generally are higher. Thomas Kuhn talks about on page 164 about, and he says basically that scientists don't have to worry about the public's opinion on things. They have to really worry about okay, if I publish this, am I going to get laughed at? Or am I going to be taken serious by the scientific community on an issue? And so, that actually helps them because, they may say something controversial and some guy said, hey, I saw this video about something, this is wrong. So It's good. Now, I will say, with scientists writing for scientists, this definitely, you could tell this book was written in the middle of the 20th century, because now with the advent of the internet, that, you get contributions by like people like, amateur astronomers a lot. And this is very valuable data for people, because we're all about collecting data in this century so far. So, but, at the time, this was made more sense, because the public was not going to have as much information. This is the beginning of the space race in the 1960s. Not beginning, but like it's the foundations of it. So, okay. Yeah, and that's the thing. So the bad side of this is it can be clouded by insider theories. People don't want to change their paradigm. Sometimes they do, sometimes they don't. It kind of depends on the subject. So that's essentially what it goes. And this is very valuable for today, kind of like working on like thinking. A word that goes with this is the Overton window, what people accept as true, maybe shaken up very drastically. A famous example, of course, is the theories of Albert Einstein, which were the gravitational effects on planets were demonstrated with the transit of Mercury in the World War I era period. And that was huge, because it basically proved that Newton was not comprehensive. And, Newton was not challenged a lot until Albert Einstein. He was challenged on certain things, but his theories, but not the foundations of them. Everybody knows their F equals ma. If a body in motion is act upon another body, then it will have a opposite equal reaction, and so on. And body in motion tends to stay in motion, that kind of thing. Those theories, and so it's very important for these to, be challenged, but not in a way that's not productive. Or I shouldn't say that, but not in a way that's not, like, if something's been done, you should look at what's been done first before trying it yourself, to get a good idea of foundation. So yeah, I think this is definitely good for anybody who's going to, do philosophy or get into scientific ideas. History of philosophy is definitely a field that I feel could have more contributed to it. And I think it's a hard read, but I think it's valuable. I think it's a valuable read, Thomas S. Kuhn's book. I'm glad I read it. With that being said, I think that now with the advent of things like podcasts, educational podcasts and videos, we're going to have a more wide, we're basically getting the benefits of both worlds now. We're having the tight-knit community getting advantages towards their scientific development, and even we're getting some people who may have not joined the field if they didn't have access to this third-party stuff. So I think more information is always beneficial, and I think that we can all learn to not, be stuck in one mindset with our paradigms, because we don't know if it's going to be challenged. Some things may not, but some things very well could, and it might be a culmination of multiple different small paradigms that lead to a bigger problem being solved. All right, that's all I wanted to talk about this book. Again, The Structure of Scientific Revolution. I read the third edition by Thomas S. Kuhn. I think there's some value in this book, and if you get the chance to read it, I think you'll get something out of it too. All right, thank you, everybody. Have a good night.